We talked about how, oh, if we just put them horizontal, they would line up. Why aren't they just horizontal? What is the purpose of the louvers? Shade. Exactly. So rather than letting the light in, which is a great idea, we actually want to block the light out. Now, how do you block the most light out? What do you want? What's the relationship you want between the louvers and the sun? Yeah, perpendicular, right? We can actually, one of the things we talk about in mathematics is finding mathematical equivalences. And so we could think about blocking light. What other thing might we put on a roof where we want to have the most interaction between sunlight and the thing you put on a roof? What's something? Solar panels. And what are we trying to do in solar panels? We're trying to collect the most light. And so you can imagine trying to collect the most light, it's exactly equivalent to trying to block the most light. So we see that mathematical equivalence, and now we can use the mathematics that's developed for solar panels to understand the best angle to put these on. And here is the globe. And again, I ask you, so if we're trying to block the most light, why aren't they just pointed straight up? The sun's at an angle. Why isn't the sun directly overhead? What? Well, the seasons, that's true, that changes the angle, but let's take the spring equinox. Why on the spring equinox is the sun not directly overhead? All right, we're not on the equator. So here's the Earth, here is the equator, and Dallas, sadly or happily, depending on your weather preferences, is not on the equator. Instead, if we took an imaginary point at the center of the Earth, it is 32.8 degrees north latitude. So if we imagine the sun, note diagram is not to scale, and all the light coming in from the sun, if we want this to be perpendicular, we can now draw a giant triangle, and we can get the angle that we're gonna tilt them at is that angle. And if you do a few congruent triangles, I won't take time to draw the diagram now, you discover that that angle you want to tilt them at to be perpendicular is 32.8 degrees, same as the latitude of Dallas. Now, does that mean that these are pitched at 32.8 degrees, or that you want to put your solar panel at 32.8 degrees? No, it doesn't. Now, why would that be? We just figured out that the sun gets up to 32.8 degrees here in Dallas. Why wouldn't we put our solar panel at 32.8 degrees? Rotation of the Earth. Does the sun start in the morning at 32.8 degrees up in the sky? No. Much lower in the sky in the morning, much lower in the sky in the evening. So you actually want to use a slightly less of an angle to capture more sunlight when over the average of the day. So you want to find the angle that's going to, on average, give you the most blockage of the sun. Turns out, again, like I said, we can leverage on the mathematics. These are solar panels to get that they should be put at about 28 degrees. Well, if they were pointing due south, and although Dallas is on a grid, it's not perfectly aligned. So there's even another calculation which we won't get into.